This is Nitin Dahat with the Times, and I'm here at the University of Oulu in Finland, talking to Mehdi Bennis, who is the one of the professors at the 6G Flagship program here in Oulu and Finland. Mehdi, hello.
Hello, nice to see you, and looking forward to our discussion.
Good. So we in E-Times we've covered 6G since our first visit here in 2018, and we spoke to Professor Ari Putu, and he gave some very good insights into the program. And essentially, the elements of the program are still the same, but obviously 6 years on, almost 6 years on, there must be a lot more of new development. So what can you tell us about what's happened maybe in the last 12 months?
Right. So in fact, the vision of the flagship, let's say, has been evolving, of course, since last time you've been here. So we've seen recent developments, obviously in machine learning. As you know, the advent of large language models had to have an impact on communication, control, and many other verticals. So we've been looking into how we could build new telecom GPT type foundation models to optimize the network. So this could be to optimize the signaling between base stations and users. This could be to come up with protocols, for example, for verticals, say your robots in a factory. So this was a big part of the flagship, which was not obviously part of the first 4 years, you can say. And then obviously we've seen recent developments in reconfigurable intelligent surfaces.
Yes.
This is one of the new keys in the block, we can say, right? Yeah. The ability to alter your reflections so as to improve your coverage, increase capacity, so on and so forth. So this is on this front. And then of course there are the other verticals, obviously. So automotive industry is also very important, because mainly due to the multimodal sensing fusion part of it. So as you know, so the sensing, compute have been evolving on their own, but now we see actually the need to really glue all these components to enable new applications which were not possible before. So the idea of even doing cross-generative models. Say you have a vehicle with the LiDAR or radar and other modalities, and maybe one of your sensors goes down.
Yeah.
So now with generative AI, you could, for example, generate the missing portions of your scene, right? These are very exciting use cases that also gave rise to this kind of new foundations of semantic communication. So
we're going to talk about it in a minute, because we had a very good discussion over lunch.
So other development, of course, we've seen that now we have seen the 6G requirements are kind of almost set. So we see the usual requirements, which, for example, take 5G requirements in terms of bandwidth. Go for 1 terabits per second. Some people are not comfortable for that. There may be reasons, but for some very specific, say, shower-like data in a mall for kiosk, downloading your movie, maybe it makes sense, but of course we see other technologies that kind of go the other way around, meaning no need for more base station deployment, more bits per second per hertz, more frequency. We could perhaps try to still squeeze most of the current frequency bands. This is one development. And of course, on machine learning, we've touched on that. Machine learning is all over the place, meaning at the physical layer to layer 2 for Mac, to transport layer, application layer, is all over. I think this is a worldwide phenomenon now. And then, of course, energy efficiency has always been there, but now we see it as a major.
It's becoming more visible as to being an issue.
Right, absolutely. So thanks to maybe climate change, we can say this has forced us to rethink the way communication is optimized. Machine learning is very data hungry, but also energy hungry. This is something that people don't pay attention to. So we now have been looking at this kind of how do you compress a model to run it very fast on a low kind of a microcontroller or resource constrained device, without really just over provisioning this model, which consumes too much power, right?
And you're not isolated. You're working as part of a global network of research groups. So it's I think we were hearing that you've got lots of collaboration with lots of different countries.
Well, absolutely. Flagship, because we were the first, of course, 6G program in the world back in 2018 now. And ever since we've seen, of course, a lot of interest groups, a lot of countries, US, Korea, of course, China, Japan, So we've signed a lot of MOUs, kind of to be able to discuss, collaborate, and yeah, we've seen really a lot of kind of positive signs on that effort, and this has been seen through a lot of EU projects. So we have many EU projects, European Commission type of projects now. I myself have 6 at the moment. Many of my other colleagues do have. So we really.
And, I mean, what are the key areas that Oulu is either expertise or has some research breakthroughs that you think are very important as part of this whole sort of global knowledge?
Yeah, so of course Oulu, I mean, historically has been a kind of a wireless powerhouse in Finland, right? Thanks to Nokia, but this was many decades ago, even before I came to Finland. But right now, still, I mean, we have a kind of expertise, you can say, in communication. So of course, physical layer, MIMO. We have done a lot of research in multiple input, multiple output, and of course, going to the massive MIMO, which is a key technology for 5G, but obviously also for 6G. And then the AI. So on the 3rd floor of our faculty, we have a very strong groups in machine vision, machine learning. So, and then of course we have also, I mean, some of my colleagues have been looking at new ways of new materials. We know that, of course, speaking of sustainability, it's not only looking at the link level or network level, right? We need to look at new type of sensors, new materials, where AI, for example, should play a big role. So kind of 6G, we see it as really a holistic technology. It's not just communication or control or materials. It's really the whole, you can say, ecosystem, right? Food chain. And Oulu has been very successful in this regard. Of course, I haven't mentioned cybersecurity.
Yeah.
It's a significant topic these days. And what else? But again, I'm a professor, so I just have my focus.
So, let's now focus on you a little bit. So what's your role? Because, I mean, obviously there are several streams in the 6G flagship. Right. You are one of those 4 streams of the sort of strategic research areas. Is that what you call them?
Right, okay. That's right, yeah. So since day one, so this is 2018, 2019, so I've been responsible for the pillar 3, which is which deals with distributed computing or edge AI, so running AI not on the data center anymore in a centralized location, but fully distributed in the network. Could be your sensor, your camera, your vehicle, and this gave rise to very interesting business models, because now you no longer share the private data, right? You share what we call models over the air, aggregate them, and it allows you to train these models again in a privacy preserving manner. So we were actually one of the first groups in the world to look into this. Later on, I was invited by Google, in fact, to showcase how come federated learning can be applied, because federated learning was their own baby.
Yeah.
But they were looking at how can this be leveraged for other verticals.
Right.
So communication obviously is a key one, because it's a natural.
I think Apple has also been doing some.
Apple
some
has
work
been
in this as well.
significantly, although maybe more secretive. yeah, sure. Once you have data on a device, you have to deal with this problem of training a model, personalized model, right, without sharing your private data with other partners, right, other third-party partners. So this was the pillar, and of course we have looked at it, let's say, through various metrics, like how do you ensure robust model, how do you ensure, for example, the energy efficiency part of the model, right? We looked at this really requirements, you can say, of Edge AI, and now this is a whole topic on its own. It's grown ever since 2019, now it's 2024, and then around 2021, you can say, during COVID, so I came to the realization that we were missing something big. Because right now we've been looking just at the bigger model, the better. Maybe taking the 5G requirement and multiplying them by 10, 100, it just didn't make sense. So this was a bit my playing devil's advocate with myself, first of all.
Yes, that's right. And then this is the way we get into semantics. But I think we were having a discussion earlier. We're just sort of doing incremental or revolutionary technologies as to actually thinking something new, and I think that's kind of where you're coming from.
Absolutely. I think now I'm really convinced that we need to so it doesn't mean it's 0 and 1, right? So we can keep looking at the current vision, but somehow try to kind of spin off a different vision which kind of goes against the requirements we see today. So today, as I told you, we see, if we take the ultra reliable reliability requirement of 5G, which is, for example, 5 nines or 7 nines, 6G came and said, you know what? If it was 5 nines in 5G, let's do 20 nines in 6G. I mean, just even laws of physics, it doesn't make sense. But of course, this is premised on the fact that you look at the requirement only at the link level, right? Whatever I send you has to be received exactly as it is at the receiver. That's not what. So this is of course rooted in the kind of fundamental communication theory principle by Claude Shannon, 1948. But in fact, going back to doing some history, in his own paper, he warned us against using his definition of information to look at a problem, for example, related to collaborative robots. These are settings where you cannot just rely on Shannon type of information, which is a probabilistic type of information, right? And it turns out that there is this 3 levels of communication. So level A is the idea of I send you a message and it has to be reproduced, decoded exactly as it is at the receiver.
Correct.
There's a level B, level C, which has been hiding a bit. So level B says you need to communicate the meaning to the receiver, not the data. Okay, so this somehow was hidden somewhere, and now of course it's time to dust it off. And level C is the effectiveness problem, meaning how can the receiver now act upon the received meaning of the data to solve a task. This could be a collaborative robot, this could be a remote...
and that would be more like the way brain thinks as opposed to what we're trying to do today, is that right?
Absolutely, absolutely. So the way, I mean, if we try to be inspired by cognitive science or neuroscience, although it's still a kind of also open problem, we see in fact, of course, our eyes, they receive very high dimensional sensory input, right, through our retina, and then of course that data is in fact compressed, right, and then it goes to maybe our short-term memory, and then we have this other module, which is the kind of course, the working memory, but also the world model. So today, what's actually missing in communication, in semantic communication, and interestingly enough, in machine learning, the idea of world model. A world model is the ability not just...
what model?
A world model is called, yeah. So model of the world.
Okay.
Physics of the world, right?
Okay.
This is something we use, of course, every day, right? When we drive and avoid accidents. So this is the ability that allows now the humans to reason, right?
Yeah.
So not just to kind of learn some sort of mappings between data and a label, which is exactly what statistical machine learning has been using. So now the ability to learn world models is in fact now something we want to imbue in networks. So we can say that networks now are reasoning. They're not just correlating statistical patterns, right, from data to solve tasks, because that requires a lot of data which you may not have, and the model will be in any case not robust. It will not generalize. Therefore now, through this lens of learning world models, it's also communicating the semantics of the data as opposed to the raw data, we believe is the right way to go, and this is also a bit validated by the trends in machine learning, in control theory, dynamical systems, or robotics, and communication. So we see kind of a unifying principle hiding behind the corner.
So I think this is okay. So you've got the communications, which is like 5G, 6G, maybe 7G, 8G, whatever. Misha Dola told me 8G will be the last, but who knows? The thing is, that's solving the network. But then what you're saying is it's not about for dealing with this whole sort of connected. Lots of data,
right.
Analysis, sensing, ubiquitous sensing.
Right.
You'll need to apply that world model.
Absolutely. Because now, in fact, and this kind of semantic communication principle, although the word even semantics has different interpretation depending who you ask, you can immediately see it. For example, if you have a distributed sensing fusion problem, right? You have sensors measuring, I don't know, maybe interference levels. Because it's an RF radar. Then you have another one, it's a camera. Then another one is maybe a LiDAR. Just the ability to glue all this information, which is sitting at distributed locations, has to be done such a way that you're extracting the meaning of all this data that is sensed by the sensor to infer an event, right? So you have, in fact, the semantics are there, but we have not leveraged them so far. Today, what we say, we have a sensor, collect a big data type of data, text, video, camera, images, which you can't even store if you are a kind of a cheaper sensor, right? And then let me train a model, right? This is not scalable.
Yeah.
This is not scalable.
Yeah. So today's sensor fusion needs a little bit more to it than.
Oh, absolutely,
okay.
Absolutely. Yeah. So, and of course, even large language models, in fact, very interesting, because large language models, you can see them through the lens of statistics, which we have seen so far every day when you use your ChatGPT 3. It's very impressive, but But of course, the amount of compute, the amount of data that has gone into training such a model is humongous. It will never be applied, for example, to other type of data. Moreover, the hallucination problem and so on are today, I mean, this is research, attributed to the fact that the LLMs today lack world models. So you see, we are back to this ability to learn a word model, not just the probability that two words appear in the same context.
Okay.
Right?
So are we, would we get to a stage where we don't need so many GPUs?
That's the hope, but let's see,
Okay.
because that will require a different type of technology, right?
Okay. So what do you want to see over the next 12 months, Mehdi?
Well, as far as I'm concerned right now, I'm just trying to actually put together this kind of vision, in fact. So I gave it a name back in the days of Vision X, trying to challenge a little bit the current visions. So in Europe, we had the Hexa X vision,
That's right.
which is exactly Flagship vision, right? And as we're discussing now, there is this complementary vision, let's put it this way, which I'm trying to put together to clarify, okay, here is where we should go, why we should go, the math behind it, but of course some people don't care so much about the math, but also the applications. Because, for example, we talk a lot about interoperability. This is a key word, but nobody can define it. And in fact, it's really related to semantics, because interoperability means a network, a functional block, in certain logic or syntax from a different vendor has to interoperate with a different language.
Correct. Yeah.
So this is a semantic communication problem. Today it's solved by hard coding the logic, not
And
smart
translating.
Exactly.
Yeah.
So now we want to completely automate this pipeline, which is a huge step. So ORAN and other type of alliances want to go there. The thing is, to really solve it in a principled manner, we need mathematics, right?
And which is your job.
That's my job, yes. And there's another one, if I may add, we haven't talked about it. Turns out also, there's a very important buzzword called resiliency.
Yes.
And if COVID had to teach us anything, it was resiliency. It turns out, and this is kind of a claim, today networks are not designed for resiliency. Resiliency is different than robustness.
Okay.
Resiliency is the ability to sustain some sort of damage or attack or link failure, bounce back very fast and sustain that operation. Today the networks are designed such that a link has to be operating 99.99999%, which is answering a different question. My question now, what if that link goes down?
Yes.
Exactly as the brain again. We have the plasticity part of the brain. How is the brain so plastic to automatically reconfigure its structure and function to continue operating? And this is today missing in synergy.
Well, let's hope you get somewhere on that. Mehdi, thank you very much.
Thank you so much.